Welcome to aminacademy.com. In astronomy, let us discuss about the solar cycle. In that, we'll talk about sunspots. The first evidence that the sun changes came from studies of sunspots, which are large, dark features seen on the surface of the sun caused by increasing magnetic activity. They look darker because the spots are typically at a temperature of about 3800 Kelvin, whereas the bright regions that surrounds them are at about 5800 Kelvin. Occasionally, these spots are large enough to be visible to the unaided eye, and we have record going back over 1,000 years from observers who noticed them when haze and mist reduce the sun's intensity. Next, the sunspot cycle. Between 1826 and 1850, the Heinrich Schiebel, a German pharmacist and amateur astronomer, kept daily records of the number of sunspots. Magnetism and the solar cycle. The solar magnetic field is measured during a property of atoms called the Zeeman effect. Recall that radiation and spectra, that an atom has many energy levels and that spectral lines are formed when electrons shift from one level to another. If each energy level is precisely defined, then the difference between them is also quite precious. As an electron changes levels, the result in the sharp, narrow spectral lines, either an absorption or emission line, depending on whether the electron's energy increases or decreases in the transition. In the presence of strong magnetic field, however, each energy level is separated into several levels very close to one another. The separation of the level is proportional to the strength of the field. As a result, spectral lines formed in the presence of the magnetic field are not single lines but a series of very closely spaced lines corresponding to the subdivision of the atomic energy levels. Why is the sun such a strong and complicated magnet? Astronomers have found that it is the sun's dynamo that generates the magnetic field. A dynamo is a machine that converts kinetic energy, that is, energy of motion, into electricity. On Earth, dynamos are found in power plants where, for example, the energy from wind or flowing water is used to cause turbines to rotate. In the sun, the source of kinetic energy is the churning of turbulent layers of ionized gas within the sun's interior that we mentioned earlier. These generate electric currents, moving electrons, which in turn generate magnetic field. Most solar researchers agree that the solar dynamo is located in the convection zone or in the interface layer between the convection zone and the radiative zone below. As the magnetic fields from the sun's dynamo interact, they break, reconnect, and rise through the sun's surface. Now, let us discuss further details about the solar cycle. The solar cycle is a roughly 11-year period of change in the sun's activity, marked by variation in the number of sunspots, solar flares, and the sun's magnetic field. Essentially, the sun goes through a cycle where its magnetic field flips, causing a period of increased activity, that is solar maximum, followed by the period of decreased activity, solar minimum. More details about it. What are sunspots? These are cooler, darker areas on the sun's surface caused by intense magnetic activity. The number of sunspots observed is a key indicator of the solar cycle's phase. The solar cycle, also known as the solar magnetic activity cycle or the sunspot cycle, is a period of roughly about 11 years during which the sun's activity fluctuates between a minimum and a maximum. Sunspots are cooler, darker areas on the sun's surface caused by the magnetic field disturbances, and their number is a key indicator of solar activity. During a solar cycle, the number of sunspots increases from a minimum, solar minimum, to a maximum, solar maximum, and then decreases again to a minimum. This is a complete cycle. Magnetic field reversal. Sun's magnetic field undergoes a complete flip roughly about every 11 years, with the north and south magnetic poles switching places. The solar cycle is a roughly 11-year cycle in which the sun's magnetic field reverses its polarity, meaning the north and south magnetic poles switches places. This reversal is a fundamental part of the solar cycle and is driven by the sun's internal magnetic dynamo. During the peak of the cycle, solar maximum, the magnetic field weakens, eventually reaching zero before emerging again with the opposite polarity. This magnetic field reversal is a key factor influencing space weather and can lead to increased solar activity, including solar flares and coronal mass ejection. Solar maximum. This is the period of peak activity in the solar cycle characterized by a large number of sunspots, frequent solar flares, and coronal mass ejection, CMEs. The solar cycle is a roughly 11-year period of the change in the sun's activity driven by its magnetic field. Solar maximum is the peak of this cycle when the sun is most active, exhibiting a higher number of sunspots and solar flares. What is the solar minimum? This is the period of low activity in the solar cycle with fewer sunspots and reduced solar flares and CMEs. A solar minimum is a period of low activity in the sun's 11-year solar cycle, characterized by a decrease in sunspot and solar flares, while it marks a period of relative calm compared to solar maximum. It doesn't mean the sun becomes completely inactive. Instead, the activity shifts to other forms like coronal holes. The current solar cycle 25 is underway with its peak expected around 2025. Impact on Earth. The solar cycle affects space weather, the influencing phenomena like auroras, disruptions to communication and navigation system, and even changes in Earth's magnetic field. The solar cycle is an approximately 11-year cycle of the sun's activity, characterized by a periodic increase and decrease in sunspots, solar flares, and coronal mass ejection. While it influences Earth's space weather, its impact on Earth's climate is relatively small compared to human-caused climate change. Sun is such a strong and complicated magnet. The sun is indeed a powerful and complex magnet, generating a magnetic field that extends throughout the solar system. This field is generated by the movement of charged particles within the sun's plasma and is responsible for various solar phenomena, including sunspots, solar flares, and coronal mass ejection. So far we discussed about what is solar cycle and its various effects. If you have done, please subscribe our YouTube channel.